All right, so we're at the end of the class and we've learned about a ton of different technologies, but we're going to have to learn how to apply those technologies in practice. So the next couple pre-lectures and the last couple lectures in class are going to talk specifically about factors that influence your design and what to start thinking about. We're going to do some exercises in class that allow you to try and think about this for your group projects, but I want to give you kind of a quick overview of what some of these factors are and how to start thinking about them in water and wastewater treatment. So for those of you who have maybe been in senior design or have been in other classes, for the purposes of accreditation in a university, one of the things that we do is we look at whether or not students can assess whether or not certain factors are influencing design. And the 5 big factors that we talk about and things that are important for our accreditation purposes at the University of Nebraska are things that are global factors, social factors, cultural factors, economic, and environmental factors. So what we're going to do is we're going to briefly define what those are, and I'm going to give you some examples of how they start to come into play when it comes to water and wastewater treatment. So first is global. We now live in an interconnected world. It's not the case where you can just design kind of in a vacuum and hope that it works for a community. Your design actually has implications at a global scale, which is very interesting. And it's new, and it's things that we really haven't thought about in the past as engineers, but things that we really need to think about now. So global implications, how could a design for, say, a community in West Virginia impact other countries? Well, we have now international goals and guidelines. So we have something called the Sustainable Development Goals, which we'll talk about on the next slide. We have the World Health Organization guidelines on water and wastewater treatment. We have something called the Joint Monitoring Program, which is run through the WHO and UNICEF, and they collect data about water and wastewater treatment, sanitation globally. So there's now international structures to evaluate how sustainable designs are. There's now guidelines on water and wastewater treatment best practices from around the world. We're sharing information among different countries. And so many times the US EPA and the European Union have standards that are used to inform national recommendations for water and wastewater treatment. We now document many of the case studies that we work on in the United States, and those get published, and those are viewed worldwide now. So it's not just a matter of a case study being done in somewhere like New Hampshire and then that information being used in Nebraska. That information can now be used globally. And so the information that we're producing is now widely available, and it informs policy. When we also think about international policy making, specifically with water and wastewater treatment, is we have waterways that go across national borders. So the closest to us in the United States is Canada. So if you think about the Great Lakes, some of those have borders with Canada. We have rivers that go across borders, and those rivers could be potentially not only a drinking water source, but a place that we're going to put effluent wastewater. And so we have to start thinking about the connections between ourselves and other countries, because it matters quite a bit when it starts to come to these international policies and kind of global sustainability goals. So these are the 17 different sustainable development goals that exist in right now. The UN has a great website that has a link at the bottom that you can go and explore these more. But these are 17 international goals. The idea is to meet these goals by 2030. So they were made in 2015. We have 15 years, and there are indicators and targets for these specific goals. So you can take a look at some different ones. They apply all over the across the spectrum of engineering. The one that we tend to focus on the most in the water and wastewater industry is Goal 6, which is clean water and sanitation. But we absolutely interact with infrastructure goals, life below water goals, partnerships, good health, well-being. All of these have relationships to water and wastewater treatment. Another set of factors that we care about are social factors, and so these are relating to society or its organization. So there are social implications of engineering design projects, and I think one of the big ones that's been coming up recently, specifically with water and wastewater, is where things are located can result in different groups of people having better access to what we call WASH services. So WASH is an acronym that stands for Water and Sanitation and Hygiene. So there's kind of a difference between equity and equality. If you think about where you locate a drinking water plant or a wastewater plant, that has a big influence on who can use that service. The quality that's in that water can be very, very different. And if we're not providing everybody with the same standard of care, that's a really big social implication. People can also interact with water and wastewater systems beyond the service that it provides. So thinking, for example, of constructed wetlands, they're not only a habitat for animals, but can potentially be a location for recreation. So there are other implications of some of our designs. One example that I really like that's been talked about in our senior design class this semester is having tours of water treatment plants for educational purposes. That's a social implication of making a design a very specific way, making something very accessible so that people can interact with it and have a little bit more communication between the community and the design that we have. And then the other one is socially acceptable. So if you think about systems or water and wastewater systems that have taste and odor or aesthetic concerns, those are less likely to be socially acceptable. People are not going to want to interact with your system, and you do need public goodwill kind of in order to get funding for things and to really have a good solid foundation for whatever system you're making. We can also have things like customer satisfaction surveys. That's done a lot in the drinking water industry to ask about how customers feel about their water, and that's really important. So there are social implications of any design that you make. One figure that I really love personally is this difference between equality, equity, and justice. So when we talk about social implications, sometimes we think of equality and equity as synonyms. Equality, the idea is that everybody gets the same amount of help to overcome a barrier, whereas with equity, you get the amount of help that is necessary for you to overcome that barrier. And then we have this third category of justice where you remove the barrier completely. And I just like this figure because it kind of gives you an idea that there is some differences between those. So I just want to make sure that we mention that because we do try and we tend to use those terms interchangeably and they do mean different things. Another factor that we consider is cultural. So this is relating to ideas, customs, social behavior of a society. And so I like this little figure on the right that gives you some other words to maybe think about when it comes to cultural attitudes, food, religion, behavior, language, customs. So it's really related more to society as a whole. Many times it's hard to figure out what the difference between a social and a cultural factor is. So sometimes we say sociocultural factors. And it's really difficult to differentiate between the two, and that's fine because they are interconnected. In general, how I kind of think of it is that cultural is about the community as a whole, their beliefs and their preferences as like a collective. And then social is about interactions between people and their community or interactions between people and the system. So cultural tends to be more about if we're locating it, say, on a Native American reservation. If they have specific cultural beliefs about water, that's something a little bit more related to cultural beliefs. Whereas social, many times, I tend to think of as an individual preference that's specific to a person or a society. Again, they're very, very similar. The other thing with cultural is sometimes thinking about appropriateness of technologies. So one question that I've posed here is it okay to add lots of chemicals to drinking water for treatment purposes? We add chemicals for coagulation, we add them for disinfection, and they're very commonly accepted in the industry. But in many cultures, adding chemicals to water is actually considered very detrimental, and it's not something that they would prefer to do, so they would prefer technologies that do not add those chemicals. So that's something to be aware of. And then thinking about whether technologies align with specific beliefs about what is appropriate. When we think about sanitation in developing countries or low-income countries, many times we think about moving from open defecation to latrines, which is a very simple technology. But many times where you locate those technologies and how those technologies are set up, even a latrine can actually be something where there's a lot of cultural input to that design, and that's really important. We can also talk about environmental. So it's related to the protection and continuation of the natural environment. Many things that we think about when it comes to environmental factors tend to be materials used. So some materials have larger impacts on the environment, maybe CO2 emissions, acidification, toxicity to aquatic life, those kind of things. And they can have different impacts based on what stage of life the material is. So we have to extract materials, and that can have impacts. We have to transport materials, and that can have impacts. We use the material, which also has impacts. And then where the material goes at the end of its life is also important. So do we dispose of it or do we recycle it? So many times when we talk about environmental factors, we're talking about materials that we're using. So one really good example in water treatment would be the difference between a concrete contact basin and a fiberglass contact basin. Those two materials have different impacts on the environment, and is something that we should probably think about. Where systems are located is also really important from an environmental perspective. So is it going to have an impact on the local environment that's detrimental or possibly beneficial? When we're thinking about wastewater effluent, what are some downstream impacts? Thinking about cross-border, right? If somebody is in the United States and we're discharging wastewater effluent and that goes across the border to Mexico, what effect does that have on the environment? That's actually really important to consider. And then we also think about how things can be reused or made more sustainable. Really, really important. The last one that we talk about quite often when it comes to design is economics, and most of the time it's related to the cost of a system. Excuse me, many times we talk about two different types of costs. We talk about the initial capital cost, and that's the money to install something in its first year, right? That's, you buy it off the shelf, that's the capital cost. We also have what are called ongoing or O&M costs. So O&M stands for operation and maintenance. And these are long-term costs that are related to maintenance, upkeep, and longevity of the system. And these can accrue quite quickly. So the upfront cost may not be that big, but the downstream kind of long-term cost can be very large. And then economic factors are bigger than just the price tag on something, right? It can be related to job opportunities, providing long-term or short-term local employment. If you create a water or wastewater or drinking water plant, you're going to create jobs, and that's important from a long-term longevity perspective in terms of community growth. You're also going to generate revenue from providing these services. Water is not free. You pay for the water that comes out of your tap, and there's money associated with that. The treatment plants also has to make improvements over time, and that costs money, and many times they have to hire engineers to design and consult in order to have those designs to move forward with the thing to improve their systems. And so there's other costs associated with this that are really important to consider beyond just kind of what the price tag is when you initially install a water or wastewater system. The other kind of factors that we consider, we've kind of lumped together for the purposes of water and wastewater. So the other three are public health, welfare, and safety. So by design, most of our water and wastewater systems are designed to protect public health by limiting exposure to harmful substances that people can come in contact with due to being in contact with water, ingesting it, having it against your skin, that kind of thing. So safe water, is really about improving health, and safe wastewater disposal is really about also protecting the environment. I apologize, it didn't show up on this slide. We also improve welfare of people. So studies have shown that when people have access to water and sanitation services, they have more time for other activities besides water collection. They're likely to live longer and live healthier lives because they're not exposed to potential pathogens in either water or wastewater. And they go to work more often, are more focused. And so there's this huge benefit of increasing kind of the welfare of everybody by protecting their health in the systems. So really quickly, because I know this has already been a long video, I want to talk about one example that we're going to work through in class. That's from the Canadian Arctic. So nice far north, a little bit different water wastewater system than we've seen in the past. So infrastructure in the Arctic, you cannot bury anything underground in the Arctic because of permafrost layers. And when the permafrost layers freeze and thaw in different seasons, it shifts soil around and can cause shearing of pipes. It can cause massive issues with foundations. And so what happens in drinking water and wastewater systems in the Canadian Arctic, and actually in Alaska as well, is we actually truck services. So that's what you see in the top right. That is a water hauler. And so they get their water from a source water, they treat it, they pump it into this tank, and then it's delivered to each home. And then there is a separate tank where your wastewater is collected in like a septic system. It's pumped out and it's removed. So there are no centralized services. Every person has a household tank. The truck does its best to deliver to everybody when possible, but you can kind of see that this is a very remote community by this picture on the bottom. And infrastructure just looks completely different. And so there's some interesting factors at play here that you probably want to think about. So there's some problems, right? Constructing and maintaining infrastructure in the Arctic is very difficult. There's no ability to bury infrastructure. You can't get large machinery up into the community many times to install things. Electricity and Wi-Fi access is intermittent because there's an unstable power grid. So there's some things here that are happening that are really, really interesting, right? From an environmental standpoint, very, very difficult to transport materials up to these locations. It's very, very costly to maintain these types of systems. And there's kind of a social consideration of equity, right? Is everybody getting enough water when they need it in this community? And one thing that I think is really interesting about infrastructure in the Arctic is that there's this web of people that are involved in this infrastructure. And there's a lot of things that you don't really know unless you start to talk to people in the community about these specific design factors. So many times you can't get materials to these communities except for once a year by barge. There's no access road. It's primarily air and sea. So that has a lot of implications on the transport of materials, right? We talked about how there's an environmental impact associated with transportation. So sending all these barges up, that has a huge environmental impact. Climate change is altering permafrost layers, which is leading to collapse of existing infrastructure. So there's a need for more sustainable solutions. So they're having to pay a lot of money right now as a result to try and upgrade these systems. There's also some really interesting traditional beliefs about what we call the sanctity of water that lead inhabitants to use glacial water as their source. So many cultural beliefs in the Arctic are associated with the Inuit culture. And in the Inuit culture, you do not interfere with the natural flow of water. You don't want to add chemicals. You don't want to change the water. So they don't prefer to have chemical disinfection. They do, however, think that UV disinfection is acceptable because UV mimics the rays of the sun, and that's a natural process. And so designing a system here is really, really different from designing a system in other cultures, because that specific cultural belief does influence some of the preferences we have for technologies. And then there's a lot of politics going on. So there's social interactions between people that are causing changes in funding and economic factors as well. So any sustainable solution in these particular communities really has to focus on traditional values. You have to focus on something that's easy to maintain, the climate, and then how local funds can potentially support people. And so it's a really interesting situation where a lot of those global, social, cultural, all those factors do have quite an influence on what you choose for design. So that's just a very high-level overview of this particular community. We're going to talk about this in more depth so we can kind of, work through these different factors in class. But this pre-lecture is designed to be an overview of some of those factors and give you a start of an example that we'll talk about more in class. And that is going to conclude our pre-lecture.